You are the only participant in the conference. You are the only participant in the conference. You are the only participant in the conference.
They basically are the same. I don't know if we necessarily have to. I mean, like, we must have constructed a postcard on there. It's only, they focused on the
My browser, because I haven't gotten a chance to organize them, so I'm sorry about that.
Yeah, special.
Maybe just type in run fast.
So
Like right now.
I can just type in run fast. The postcard.
You are the only participant in the conference.
So, which file is that use? I'm gonna try also. No, number of processors must be between 110.
Huh? So, right now it is on yours. So, who's the
You are the only participant in the conference.
Do anything. It's very research for it? Gonna get some research for it?
So these are structure for yours. You can add the information.
You are the only participant in the conference.
You're on.
Yep.
So what do you think? I mean,
Avaya. The conference is now starting. You are the first person to arrive. You will now be placed into the conference.
So, gentlemen, if you want to
We're trying to, I'm trying to figure out the density of states.
no, it's too early.
Oh.
Too early.
Oh, I didn't know which one to look at.
Let me navigate. So through these materials, please try to identify how to prepare POT, podcast file, with information about elements. It's very short operation, it's like 10 seconds, but try to browse through and identify. So before we prepare all 4 input files, we cannot run for our training structure.
Okay.
So the unit cells here to the this should come. This is just here to the center. Everything except for the
Yeah, no, I'm gonna out.
There should be something not zero, just potential just one. So it's more, so
I don't know what these cues here.
This is more like this just difference between big box and small.
So the second two.
If we this seven is minimum.
I feel like we might have to put in the H with a T.
Still isn't such one.
This zeros means that it is sometimes
Yeah, I'm
I'll go forward. Did you found the way to create Oscar file?
Yeah.
Did you practice creating it? Huh? Scared?
Just joke that I'm always too scared to like lose where I'm currently at and not be able to get back there, so I didn't mess around with it.
So, where are we now? So, a little reminder who we are and what are we doing. We need 4 files in order to just do simple run of us. We already have first file. It looks healthy. I'm happy. I saw it that you have it. Now, in car and key points, there will be templates. In car is same as in selecting charge, multiplicity, basis set, task to optimize or find normal modes. Key points is to tell whether you allow electrons to move as a whole with some velocity. But there are template files. The thing that we always need to do ourselves is podcar. In Gaussian, this is inserted inside unless you are doing effective core potential for exotic elements. In VASP, you need to provide potentials for each element. So they have different research groups. One research group does actual software, and another research group prepares elements, potentials for elements, and they updating it from time to time. But if you have seen POSCAR, it has labels like titanium and oxygen. But in fact, the software, when it will be running, it doesn't care which labels, which alphabetic labels you give. You may call it, you may write O and TI, or you can like tell A and B. It doesn't matter. These words mean nothing. It is only for humans. For code, it needs specific file that records information about background field created by core electrons exerted on the valence electrons. Okay, so it is a general idea, and it will be stored in the file podcar. There will be directory for each element. I will show you where. Instead of letter P, it will be like podcar, PAW, and then there will be subdirectories for each element, and subdirectory will contain podcar for one element. And then we will need to pick right elements and merge them, concatenate them into a single file. It sounds scary and long, but it is just one quick line. But let me show you. So CAT stands for concatenate, not for the cat with whiskers. Then you need the sources of the individual elements, and then you do bigger into the target file. So CAT. Oh, head POSCAR. So first oxygen, second titanium. CAT potentials oxygen slash podcar bigger podcar. Then TI. Okay, I'm done. So this directory potentials, if you look inside, it will have all periodic table, all elements, labeled according to our common names. And in each element subdirectory, there is a file podcar that contains potential for each individual element. Now we need to add them to the podcar that is located in our target directory in the right order. If you swap the order, it means that you swap the elements. It will be like oxygens titanium 2O, which will become stoichiometrically wrong. So again, do not mess at this point. And upon you did this step, you can see LS minus OT. You can see that the podcar file is not terribly huge, but large enough. It is recorded in the text format. Humans may look inside, but it is too large to inspect. I discourage you to look inside. It is boring. But there is a way of quick check of sanity check to double to inspect whether it has needed segments. So here is this sanity check. So grep, PAW, podcar. Grep means to parse a word from a file. PAW, it is the method that is used to create potentials. Right now we don't care, but it is projected augmented waves. And it shows that first it has oxygen, second it has titanium. So our file is good. And if you have a model with like cadmium, selenium, nitrogen, oxygen, carbon, you may make this and make sure that your podcar has all potentials, all elements. So it is critically needed for successful run of the VASP. And I promise, some of you will do such error. At least one person in the course will mess up the order, and that get very strange electronic structure because the like it will be, for example, instead of titanium 2, it will be titanium 2O, or something more crazy. Just be careful. I'm going to walk and see that you all have this file.
So what are those numbers that sit next to all of those lines, like the 1 next to the PA, the 8 to the TITEL?
Oh, it is line number 1, line number 8, line number 18.
Okay.
So if you type grep -n, it gives the number at which the keyword appears.
Okay. If you don't, then it doesn't pop up those lines.
Correct. If you favor Microsoft Word, you can just type find and give a regular expression, and it will highlight and tell next.
Yep.
It is grep is the same,
Okay.
but it was created just maybe 40 years before. And originally, people were not writing like theses or poems in computers. It was used only for programming. So if you need to find specific command, you just scroll through and then look into the right place into file and correct it.
Okay.
That's the first thing I did.
I don't have it.
Oh, it's a
Before we go, we need to first is oxygen, second O is not O. See, it has rockers model values. Now it will
So it just has to go on what we did now.
yes, 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 yes.
Yep. That's
Okay. Austin? You got it? Okay. We are almost there. For the first glorious run of the WASP. So, I invite you just to copy the template of key points without looking inside. Copy into this directory, and if you're curious, you can look inside. And right now, this key point file is for chemical molecules. The last line, these three numbers, 0, 0, 0, it is components of the momentum of this overall electronic cloud in X, Y, and Z. And if the 0, 0, 0, it's same as staying without movement. But it has an opportunity for everything moving like a plane wave across. So there could be like, especially along X, for this model, it could be different numbers. Right now we do not need it for the first run, but later we will practice it. So we have 3 out of 4, right? We need one more. So I invite you to copy the template, GM for geometry optimization, space, period, / incar. So WASP is useful, but it is not forgiving in the sense of names of files. So there are standard names, and if you miss the right word for the file name, it will just not work. So copy this template into this directory, and then look inside. So through the course we will learn about this stuff. Right now we do not need to know. We will just run as a template. Remember, on your presentation, someone told how to change number of cycles.
Vijay.
Who?
Vijay.
Vijay, yes. Electronic cycles from 130 to 500. There is a way to change a number of electronic cycles. It is not here, but there is also, right now, it is a template for geometry optimization. Just right now, in order to save time, we will do single point. But optimization here is also very quick. We are just talking about 30 seconds versus 1 second. So the number, you know, we always go through algorithms that have a stopper of a programmer sitting in a bathtub, when the conversion criterion is matched, or when we are tired of making too many cycles. So right now there is a breaker for number of cycles. This NSW, it is number of cycles for geometry optimization. If we set it NSW equals 0, it means do not optimize geometry. Just stop after first, just do 0 geometry cycles. Do electronic, single point, and do not change geometry. Make sense? And the rest is fine. We do not need to change anything else.
What does it mean by the silver plus carboxyl?
You can write your name and tell, like, Christian Newis is Emperor of the Universe. It just comment.
Okay.
12 years ago, I was running this system, silver nanocluster, growing of the cubic or triangular silver nanoclusters, but by putting the citric acid. And through this practice, I just developed a file that was working well for me, and then I was using it again and again, and was lazy enough so that I didn't change it in 12 years. But first line means nothing. Thanks for being careful and attentive to all details. So I'm going to either VI or nano for in car, and going for this NSW and making it 0. True. And just before running it, I want to copy this steps into PowerPoint so that those who didn't have chance to come today may overview what we did. So if you look on the files, you do see that there are 4 files named postcar, podcar, in-car, kpoints. Please raise hand or give me some other signal if you don't have these files. Make sure that if you do ls-lt, you have these 4 files: postcar, podcar, kpoints, in-car. Do you? Yes? Daniel?
Yeah.
Okay. Christian?
I'm working on it right now.
Austin?
How do you get out of Daniel?
Huh?
How do you get out of Daniel?
Control O. Control O and then enter for saving file.
Oh, right out.
You got it?
So I changed it to 0.
Okay.
So that's good there. I'm just trying to exit this now.
Control O. Simultaneously keep hold control O. Then enter. No, enter after. Let me try.
I'm not even getting into work.
So I stand mode now. I get in there and I just never get out.
Controls. I have forgotten.
Okay.
So you all go ahead.
Yep.
Now, guess what will be the command?
Run the job?
Yeah.
Oh. Just straight run fast, nothing else. Oh.
Yeah. Well, later we will specify number of processors and the If it is educational, simple run, like 4 would be optimal. But for this pathetically small, even 1 processor, you'll be fine. Yes?
So since you don't need the file name, does that mean you need a new directory every time you do one of these?
Good question. I was strongly recommending you to open new directory for each model you do. It is because of specifics of file, of WASP. So it looks into the directory from where you executed, and it expects that there will be only unique set of input files. POSCAR, PODCAR, INCAR, and kpoints. So you cannot have more than 1 set of input files in 1 directory. So there is no ambiguity. Just each job, each new directory. And you encode, like if you do Gaussian, there is a temptation to have like 100 jobs in 1 directory. And you encode type of your chemical system or your job in the name of file. Here you do not have this luxury. The names are standard, but you can create directory and encode all informations in the name of directory. Okay? Make sense? So after you run, it gives you the job ID, and then you can qstat and grab this number and see whether it is running. Okay, mine is not running, which means it was either error or it was complete. And if I do just qstat, I see that 3 jobs are running. Maybe some of them are yours. So ls minus lt. See, it suddenly popped up to like 20 new files. If your job is complete. So if you do, if you see that your job is not running anymore, you can do tail out car and see if you see the records of spent time. It means it is successful completion. Did you got about here? Just less minus OT to see. Austin? Okay, so right now, if you are not yet exhausted, you can go to observables, density of states, and just analyzing output. But record your emotions and impressions and steps. From now on, you can do competitive research and publishing.
You're saying Gaussian's not good enough for competitive research?
It's good, but the start doing calculations in Gaussian, the entrance barrier is so low, so that everyone does it.
Okay.
So do not forget. I will not repeat these steps. Maybe some of you will repeat it on the presentations for the skills. But this is critically important thing. Now, relax, take a breath and concentrate on the output. What are your observations? What do you see? So our last file that we have created is here, and here is new files 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A dozen new files. The word out prompts that likely it is similar to Gaussian out. It should be main file with service information. What else, just based on names, which guesses or which intuitive understanding of the names do you develop?
Guessing wave car has to deal with something with waves.
Yes. Wave car, in some sense, it is similar to check file in Gaussian.
Okay.
So it is where orbitals are stored.
Okay.
Okay?
The density of states are
Huh?
loss bars and that's
Yes, but we will not use it. I will offer you homegrown codes that make it much nicer.
Contour car, I'm guessing, or the cont car?
No.
C-O-N-T.
Good eye. So it's not for contour. It is for continuation.
Oh.
So sometimes resources of your computer system are limited, and or system administrators do not allow job to run long enough. So you run a job for a specific number of steps, then you save intermediate data, and then you continue again. So if you would do geometry optimization, the optimized geometry is saved in cont car. So if you look on the cont car, more cont car, you see a pattern that you recognize again and again. So it looks in the same format as postcard looks. Right now, if you compare the data, there will be nothing changed because we intentionally requested 0 optimization steps. But if you allow more than 0, it will slightly change positions of atoms, and they will come closer to the global minimum. So cont car is optimized geometry. Or if you do several steps, it is intermediate geometry. Or if you do molecular dynamics, it saves a snapshot of molecular dynamics. Later on, I don't want to give too much information, but after coordinates there will be velocities, momentum, if everything is moving. Okay. What else do you observe?
Eigenvalues.
Yes, yes. There will be energies of orbitals, but they are duplicated. They are also available in outcar. There is an interesting Aussie car, and I do not have a guess what does it abbreviate for, but I know what is inside. It's not like Wizard Oz, and it is not oscillations. It is records of the self-consistency steps. If you look inside Oz Z car, this file is being recorded while it is running. You can look if you have a long running job, you can look in the file, and it will grow slowly. So the last record shows how far your total energy is from convergence. So it is the diamond symbol on the flow chart, the tolerance limit. So it stops when the tolerance is less than 0.02, 0.01. So 10 to the minus 3, it's small enough. And before it was not matching this precision. So it repeats until the precision is matched. And you see that it is matched in 23 steps. So the algorithm for DFT, which was used here by definition, is similar to Hartree-Fock, and it is the cycles over self-consistent procedure that we were doing as a flow chart on Tuesday. So 23 steps, done. And this F is for free energy, total energy. So minus 101.66 electron volts is total energy of the system. Okay, I do have two goals which we can try to match. First, how to do density of states, and second, how to visualize orbitals. For orbitals it is too long, maybe how to visualize, Daniel? What were you presenting last Thursday?
What was I presenting? The molecular charges and potential energy surfaces.
ESP?
Yeah.
And were you presenting total charge distributions?
Yeah.
Okay, so what we can probably do on a short time scale is total charge distribution in VASP. And before this, let's maybe try doing the density of states. If we complete it, would be great. If you all get tired and vote for completing session, I don't mind, but let's try some effort. Density of states. I am going to look into the outcar. So, same as in Gaussian, it has a lot of service information that is not needed for simple guys. Typically, we look on it only if something goes wrong. But if I scroll it closer to the end, I will tell you. Okay, so near 80% of closer to the end. There is a table of the format that you will recognize and probably enjoy. Numbers, 1, 2, 3, 4, 5, energies, and numbers which are either 2 or 0. So I did. It was not seen by those who look on the records. I need to zoom in. Okay, better. Do you see? Can you scroll and see this record? Everyone? So what is it? What is your guess? Huh? Yes, band gap and energies of orbitals, right? So there is a density functional theory uses concept of orbitals similar to Hartree-Fock. People do not like to call it molecular orbitals. There are specific names that we will introduce later, but the concept of orbitals and band gap is still there. So HOMO and LUMO, or HOR and LU, orbitals highest occupied and lowest unoccupied, about minus 0.7 and about minus 0.3. So what is the gap here? About 3. What was the gap in Hartree-Fock by Gaussian? It was something like 13 electron volts.
Oh, that was for the double.
Huh?
I only did the 2 titanium. That
It was always very large,
Okay.
over 10 electron volts.
Okay.
And if you look through like publications or just Sigma-Aldrich classification, when you purchase chemicals, it gives you basic characterization of like band gap, color. And if you ever seen titanium dioxide, you went to beach under the sun, sunscreen. What color does it have?
But you're talking about the SPF? Well, it uses titanium dioxide.
Yes, sunscreen is white, so titanium dioxide is white.
Yeah.
So it is transparent for visible and not transparent for UV. So Hartree Fock under Gaussian gave you garbage because it was transparent for UV. Right? And if you look for data, titanium dioxide gap is around 3 EV. And here we just did a first run without anything, and we are very close. There are shortcomings. It's also with these cheap methods that work in a couple of seconds, you cannot trust to each significant figures. But this is a workhorse that has a very good reputation for quick assessing of properties of materials and used by in any area of research, like not only scientists but also engineers and design of materials. So yeah. Now, do you have an idea how to make the density of states figure?
Okay, so you don't use new plot this time?
We do. So you just parse this fragment of the outcar file, right? And then process it with the same way as we did before. So you you remember definition of density of states. So you assign non-zero width Gaussian profile to each orbital energy, and then it forms continuous lines, right? Who was presenting it? Okay. In your slides, it was delta function for each energy. Yes? Let me write it because we will we will use it again and again many times. So if you have energy of a given orbital, right? You do energy minus parameter, specific energy value, discrete, minus continuous, discrete. This one is continuous. Here you do delta function, but in fact, instead of delta function, you use some Gaussian profile. It's just shorthand notation. And then you do summation over all orbitals. And you call it density of states. So if you write a paper and you show density of states image, a reviewer may come after you and tell, I don't understand your figure. Which equation was used to prepare it? So in methods, you write this equation, and then in figure, you refer. This figure is based on this equation. And then no one can harm you. You're clean. Zoom, 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 zoom. What? Okay. Just one time. So I can just copy this portion. I'm doing something quicker. Later we will go for more industrial environment. So just look for this fragment of outcar, copy it, and then create a new file which I can call like states. And paste paste this information into there. Okay? So please try doing this step. So yes.
I have issues copying things. Can you help me? So,
Okay. Oh. I don't know. So I see I highlighted, then opened file, and then put in the
the middle button?
yes.
Oh. I was trying to right click because that's how it works in other things.
Did you got this states there? Just do more. Spaces. Please scroll up to files. You Orbitals, orbital energies. Select. Yeah.
What is yours?
Did you go to states file?
No,
Jump.
you created a file to send for.
Wait. I will later do it and explain. Can you select it? Then you just do whatever, either nano or VFA. No. Create a file just by type nano. States. And here. Okay, good. Did you get it? Q exclamation if you want to use it.
Okay.
This, Q. Exclamation. No? Interesting.
My laptop's been weird today, so.
It's not your laptop.
Yeah.
How do you copy?
Either just right click.
Copy. Okay. Good. So if you are not comfortable with VI,
Yeah, I thought I was getting yeah, it worked, but it wasn't pasting.
okay. I will ask a question. Do not laugh in response, and do not give the first thought that comes to your mind.
how do you interpret abbreviation WC? Okay, now I give my version. Word count. So type WC space states. So it counts how many lines is in files. The first number, 27. Okay. I'll do something and then declare it out loud. But you can try following me now or in 3 minutes. Okay. So please try to type grep Fermi, or you can just skip first letter, outcar. Why it is needed? The density of states can be shifted left or right in energy to nothing, or it can be centered near Fermi energy. Fermi energy like energy of occupied, or halfway between HOMO and LUMA, right? And this data is computed in VASP. So if you grab Fermi outcar, it will give energy Fermi minus 6.8 electron volt. And then the corrections for exchange correlation and for possible spin effects. So this data can be used just to shift, to adjust center point of the density of states. After another piece of information. Later on, you may decide to compare density of states for models with different number of atoms and different number of electrons. If you literally practice this equation, the bigger system will have much more states, and it will be much higher, much larger. They will be incomparable. So you may want to normalize to the number of electrons, number of atoms, so that systems of different size will be comparable. Therefore, it is reasonable to feed in the number of electrons, number of atoms. Make sense? So if you do grep number of electrons out car, it tells number of electrons is 64. If you are big expert in periodic table, you may count that 4 titanium and 8 oxygens will give more electrons. But here, core electrons that are like 1s, 2s are not counted. Only whatever contributes to chemical bond is counted. Therefore, it is a little less. So you may, when you need this information, you may scroll on your window, or you may record it on your piece of paper. But now we need to practice this equation: conversion of discrete energies into continuous distribution. So this is practiced by the script, by the code dress dos norm. A connection to dress, because you have a single line for each, just single number for each energy, but you kind of dress it with Gaussian shape. And it was not changed for several years or decade when the code was written. So when you run, type this name of the code and hit enter, and then it will start. The code will start chatting with you and asking some silly questions, which you are expected to answer.
So -10. I understand the next three numbers, but why -10 for the min energy and max energy?
It's range.
Okay.
And you are master of your own files. You can start from -20, but then it will be nothing.
Okay.
Right? So you just look on the specifics of the system and navigate and select window of your interest.
Okay.
So number of states is how many records is in your file. Sometimes it can be all orbitals, sometimes it can be all only those that you have dumped into the states file. So here, in my case, it is 26, but in your case, it can be different number. Next one, minimal energy, -10 will be good. 0, in fact, I do not have any orbitals past -2, but I just put 0 because I do not want to spend my time on counting. It's kind of universal. Now, Fermi Energy and alpha plus beta. I just copy-pasted from what I got from VASP. So Fermi Energy -6.8 electron volts. Alpha plus beta. Width of each line. So it is how broadening of each line. 0.01 can be too broad. I suggest 0.005. Magnitude doesn't matter. 1. Number of atoms in simulation cell 12. Number of electrons, we already checked it, 64. Gap of bulk, whatever, 3.2 or 3. So if code is successful, it will write DOS Fermi is written. If you have something else, it means there are problems.
What if you got 8 Fermi levels? I got 8 Fermi values.
Did you change NSW to 0? It looks like you did optimization. But if you got more than 1, use the last one. Just for curiosity, if your job was not a single point but optimization, it will write Fermi energy at each ionic iteration. If you do like 100 steps of optimization, it will write Fermi energy 100 times, because at each change of geometry it may change. I will just copy this protocol to the PowerPoint and then make a circle.
So just a 0.05 for the width?
Huh?
0.05 for the width? Or would you-
0.005. 1. 12. 64. 6. 4. 3.
Okay, I was wondering, was it
Okay.
because Ian's stuff.
Did you
came
go?
over right now. Oh, yeah.
Did you get the?
Yep.
So if you look inside this file, even if you do not, you see that it is much heavier than your states file. So states has about a couple dozen of individual orbitals, and this DOS Fermi has continuous scanning of energies in the third column. See, they are offset by a very small number, very dense. But it is, one column is energy, another column is values of density of states. You see the non-zero if you scroll. But we do need a tool to plot it, right? So it should, if you do all the steps, it should create density of states where the occupied will be filled, unoccupied will be empty, and you can visualize the gap in here. So let me go through the steps of getting it. In fact, if the files are ready, you just do two commands. First, GNU plot, and then specific script. GNU plot tilde binary / GNU proc _ DOS. And you can always look inside what is in this file. It is very, you already practiced this for Gaussian output. So it's just parsing right columns and plotting them. And then after running gnuplot script, it creates dos.ps in the obsolete format. And then after this, you do PostScript to PDF write that converts into modern PDF format. And then after that, you observe that PDF file pops up in your directory, right? And if you are using MobiXterm, you can browse through your files on the left side. And if you are not practicing MobiXterm, you can do SCP to the cluster, then select the name of directory, name of the file, and transfer it to your thing. So please try to reproduce this figure, and I'm going to go around and check if you get it.
That's right. I did, since this was like, so.
Okay.
I don't know if I have
You follow me.
Yes. Yay.
You may save it as into Word or PowerPoint, just in case if there is some similar homework. Let me just
something is wrong with so it should be 11. Roughly. It should finish No, well, this is same as so nature, self-existence, you say. Electronic.
Oh, self-consistent circle.
Yeah. No. If you have nothing to do until you've done this DOS image, try to download charge card to your local computer and open it with VMD. This is a maximal 20 per day.
You may save it.
You want me to open the file with?
Huh?
So I downloaded the short files you asked.
Oh, you start.
Okay, I'll show it. Austin, did you got to download and open Daisy States?
Working on it, but I think I'll get that.
So you need, so every directory that you make, do you need to re-download, or not, like re-copy like the K points and exact stuff for everyone?
Because those are information that you may want to change. For some files, you may, if you have metals, or then you need a lot of key points, or you may have seen on the group meeting the research results of Fatima. So she does nanowires with different key points. So for her research, she needs different sampling of key points. So it is a parameter that you need to specify sometimes.
And then which one, is the in-car the one that you like do the density states, not density states, the number of states, that can do the number of states?
In-car is where you request specifics of a job, what you want to compute.
It's that one.
It's
Or
like
is it-
same as first three lines in Gaussian input.
Got it.
Still have some steam or completely exhausted?
I'm getting pushed to my limit.
What is your limit? 5 minutes or minus how an hour?
I mean, I'm getting hungry. That's my main problem.
Okay, I will just make image myself. If you get impressed, you can try it or postpone it for. I just want to show something. Okay, so I need. Car, and I need charge car. Okay. So VMD is a free code. If you, it is installed on a cluster. You can run it directly on HPC, but it is graphically intense, and it is much better to run it on your laptops. So first, it is installed on every desktop computer in this class. Second, you may download it for free and install it on your personal laptops.
What is it?
Visual molecular dynamics.
Yes. Let me just show you the.
There's a lot of different links to get it though.
Probably when we meet next time, I will summarize how to get it. You will not regret if you see. If you see it working. Wasp. Oscar. File. Thank you. Close. Charge car. Open. Final type. Charge car. Charge density up to plus that. Okay. Okay, so this is the image of the total charge density. I can probably make it better visualization with white background. So this is something instead of let me zoom in. So VASP files can be converted into the cubes and read by Gauss view, but it is an additional effort. There is a software that immediately recognizes VASP format, and the VMD is one of the software pieces. So when you want to do it, you first download, you first open the coordinate files, and then you bring the analog of cube, the distribution of the density. And then there are same options for playing with the isosurface and looking on from different aspects. So what you can see scientifically here is that the isosurfaces do not end on the atom. It kind of protrudes and repeats from other side. So it is infinitely periodic. I think everyone is tired, so probably let's complete it here. But try to do it at home, and we'll start next lab from the same images. Okay, done. Meeting is dismissed. Have a good rest, and see you. I hope you will have enough steam tomorrow to visit class at 11.
Glad it's not on a Friday. I'll be on a plane going to Vegas.
That's fine. What can we do? To just be jealous?